So this is absolute functions day 3. We are now going to focus on graphing absolute value quadratic functions. So determine the y-intercept, the x-intercepts, and the vertex every time. This is just like in past units, so that doesn't get to change. So if we look at this function, negative x squared plus 2x plus 8, our y-intercept is equal to 8. Our x-intercepts, we are looking for a value that multiplies to 8, negative 8, sorry. And a value that adds to positive 2, that'll be 4 and negative 2. But this guy is not just a classic one, so we do actually have to do factoring by decomp here. Or if we factor out this negative, so then it's negative x squared minus 2x minus 8, and we factored this would be x minus 4 and x plus 2. I would probably do it this way. This way makes more sense to me because then I just know that x equals 4 and x equals negative 2. Otherwise, if you leave it this way, you have to factor by decomp, which is fine. And we have to factor by decomp because this is not positive 1. Okay, so now we find the vertex. Look at the original for this. So this would be negative 2 to negative 1. So that'll give us 1. Y is equal to negative 1 squared plus 2 multiplied by 1 plus 8, which should leave us with 9. Okay, now we can graph. So we can see our original graph here. Now we need to reflect it. So we have our absolute value part of it. Now this doesn't have to be terribly accurate. We just have to know that these arms are going to come up this way. So this is where the piecewise function is going to get a little strange. I trust that you guys know how to do domain and range. And so let's look at our piecewise function. So y is equal to, we have our negative x squared. I'm not going to have nearly enough room. Let's move this. So y is equal to negative x squared plus 2x plus 8 if. So where does this guy exist? Where does the black part exist? Well, it exists from here. So at x is equal to negative 2 and here, but just within these points, so at negative 2 to 4. So if x is within these bounds. Now the red part exists from here on to here on. So if it is less than negative 2 or greater than 4. Yeah. So that really relies on knowing our invariant points. Our invariant points are x is equal to negative 2 and 4. Okay, next one. X squared minus x minus 2. So let's do our graphing stuff. So our y-intercept, y is equal to negative 2. Our x-intercept, and then our vertex. And then when we plug it in for y, we get 2.25. And then let's graph. And I have a suggestion here for you guys to use a scale of 0.5. Okay, we have our graph here, and I do have a couple points labeled for us just to make it a little easier to read. Now what we are going to do is we are going to reflect it. So this point down here, -2 becomes 2. Then we have 1.5 and 2.25. And then we have another one here using our axis of symmetry. So this goes over a half and a half, so it should be like right there-ish. So it should be at 1. Yeah, something like that. And then this comes up and over like that. So this guy, we get rid of. He's gone. So then expressed as a piecewise function, we have our original function. So y is equal to x squared minus x minus 2. So this exists this point on and this point on. So x must be less than and x must be greater than. Okay, and then our reciprocal or our negative exists within those 2 points. So then, sorry, those should have like that. And there we go. Domain and range, again, I trust that you know how to do that, so I'm not going to go over it, but you should be good to go to finish up your graphing.